Section 3.4, Example 3. Okay, so now we're going to use the definition of a logarithm to solve logarithmic equations. Step 1, you want to have your equation expressed in the form log base b of m equals c. Now, you will also be doing this with natural logs. Just remember, working with natural log, your base is e. Okay? Step 2, just remember that log base b of m equals c can be written this way in exponential form. Then you're going to solve for your variable, but you always make sure you check. Okay, so the first part of example 3 is pretty easy. We're going to rewrite this in exponential form. That would be 2 to the third power equals x minus 4. 2 to the third power is 8. 8 equals x minus 4. You add 4 to both sides, we get x equals 12. But we do need to check that solution. So we're going to check log base 2 of 12 minus 4 equals 3. Log base 2 of 8 equals 3. And that is certainly true, because if you rewrite this in exponential form, you get 2 to the third equals 8, which is absolutely true. So that solution checks out. Okay, so first, here we need to divide both sides by 4. So when you do that, you'll have natural log of 3x equals 2. Okay, now think of it this way. Think of as natural log being a log with base e. So if you think of it that way, we're going to rewrite this in exponential form. It would equal e squared equals 3x. And now to isolate the x, just divide both sides by 3. You get x equals e squared over 3. Now to check our answer. 4 times the natural log of 3 times e squared over 3 equals 8. Okay, the 3's cancel. So then we have 4 times the natural log of e squared equals 8. Divide both sides by 4. The natural log of e squared equals 2. Now I want you to think about a property in an earlier lesson that said the natural log of e to the x will always equal x. Okay, so the natural log of e squared is 2. So yes, this solution, x equals e squared over 3, checks out. Okay, so on the third part of example 3, on the left-hand side, we need to rewrite this as a single logarithm on the left-hand side. So when we condense this, we'll have log of x times a quantity, x minus 3, okay, we're using the product rule, equals 1. Now, if no base is written and it's a log, remember that's really base 10. So rewriting this in exponential form, we'll have 10 to the first power equals x times x is x squared. X times negative 3 is negative 3x. Okay, we want to subtract 10 from both sides and maybe see if we can factor this after that. So then we'll have x squared minus 3x minus 10 equals 0. And this certainly does factor into x minus 5 times x plus 2 equals 0. So it looks like we have 2 possible solutions. X equals 5 and x equals -2. So now to check our solutions. First we'll check the 5. The log of 5 plus the log, okay, 5 minus 3 is 2 equals 1. Okay, so we can condense what's here on the left. That's the log of 5 times 2, which is 10, equals 1. Okay, now if it's a log and no base is written, it's base 10. And so this is true. 10 to the first does equal 10 when you rewrite it in exponential form. So x equals 5, that checks out. Now let's check when x is -2. The log of -2 plus the log of, okay, -2 minus 3 is a -5 equals 1. But wait a second. The domain, meaning the x values of all log functions, have to be positive. So that means x has to always be greater than 0. So x equals -2 cannot be a solution.